Hello everyone, welcome to Saturday CSAT session. In the last session, we have covered one topic. I hope no doubts in that topic. If you have any doubts, please comment in that video. I'll reply it. And today's Saturday, we will be taking another topic, that is LCM and HCF. So if we look at the trend of questions that has been asked from this particular section, say most of the questions were asked from the LCM and its applications. So the applications of LCM are more. That's the reason why more questions came from here. And HCF, I think only one question that is also clubbing with LCM has been asked. Now, if you see the number of questions that are asked, see till 2018, there was some irregularity. Some year there is a question, some year there is no question. But from 2019 onwards, at least every year there is one question. Some years there are two questions like 2019, 2020. And 21 onwards, every year there is one question. So small topic, very easy to solve, very easy to understand, and very easy to apply. Even 2023 also, there was a question with respect to that application of traffic signals, all blinking or all lighting at a frequent intervals. Then when they are going to once again switch on simultaneously, this type of question has been asked. So in this particular session, we will look at how to calculate LCM and HCF. Then we will see the applications of it with some previous year questions. Okay. So take this as the reference and solve as many questions as possible. And that practice has to continue till your CSAT examination. So let us look at it. The approach is very simple. We need to calculate the LCM, but we need to understand what are the different types of applications that are asked for LCM. Sometimes the applications are bells ringing at regular intervals, bullets firing after some time, people going to somewhere after some time, and then some clubs, hobby clubs meeting after regular intervals. So these kind of applications are there. Let us look at it. See, in the questions itself, I'll explain how to find the LCM and HCF. See, HCF is simple. If any two numbers are given, let's say 8 and 20 is given. So the small number, we will take it as divider, and then big number we will continue to divide it. Let's say 8 2s are 16, right? So 2 times 16 you will get, and the remainder will be 4. Now you take this 4 as the new divider and 8, and again 4 2s 8. Now the remainder is 0. So you will continue this till you get the remainder 0. When you get remainder 0, whatever the thing that is leading to remainder 0, that will be the HCF of both of them. Okay, highest common factor. Look at it. 4 is dividing 8 as well as 20, and this is the highest common factor to both of them. This is how we find the HCF. LCM, we will see it in the examples itself. And here, different types of questions that are asked. For examples, hobby clubs meeting after, let's say, one club meeting after 5 days, another one meeting after 7 days, another one 8 days. So they meet at so and so day. Then when is the time all of them are going to meet simultaneously? Similarly, bells are ringing at, let's say, after 2 hours, after 3 hours, after 4 hours, as if 3-4 bells are there, and they will give the time at what time they got simultaneously rang, and they will ask you what is the next time when all of them are going to simultaneously ring. Okay, so this is again application of the LCM. Similarly, traffic signals, bullet firing, our friends going to somewhere, all these things which show you that some event is happening after a regular interval, or there is a periodicity. In these kind of questions, we can apply LCM. Now let us take some of the previous year questions. Let us solve them, and with the help of it, let us try to understand how to apply LCM and how to calculate LCM. Okay? First question. See, there are 5 hobby clubs in a college. The clubs are photography, yachting, chess, electronics, and gardening. And the gardening group, let me just write it here. Gardening groups meets every second day. So second day. Similarly, electronic group meets every third day. Okay. Chess group meets after every fourth day. Yachting group meets after every fifth day. And the photography group meets after every sixth day. So all 5 clubs are done. Now, how many times do all the 5 groups meet on the same day within 180 days? This is what we need to find. So simultaneously, how many times they meet on the same day? Okay. So this is a simple application. Whenever you see this kind of things, you need to find LCM. Okay, least common multiplier. So that multiplier is the day on which all of them are going to meet. And in a given time period, how many times that is going to come, that is what we need to see. So simply what we need to do is we need to find the LCM of 2, 3, 4, 5, 6. So what is the method of finding? Take all the numbers in this format and start with the lowest number, prime number, that is 2. So see how many numbers are going to get divided here. 2 ones. If the number is not divided, just leave it as it is. 2 twos, same. 2 threes. Then what is the next to smallest prime? That is 3. So if 1 is there, you don't have to do anything. It goes as it is. 3 ones, 2 as it is. 2 is the smallest one. And then 5 as it is, ones. Now all here, 2 is also prime, 5 is also prime. Then remaining 2 are also prime numbers. We simply have to multiply all these, and whatever the resultant, that will be your LCM of all these numbers. So kitna aega? 6 into 10, that is 60. So 60 is the least common multiplier of all these numbers. And it also gives you the hint that all these 5 clubs meet at an interval of 60 days, even though they are going like 2 days, 3 days, 4 days, 5 days, 6 days respectively, but all of them meet after 60 days. So 60th day, all 5 clubs meet on that day itself. Similarly, all the multiples of 60 days, like 60th day, 120th day, and 180th day. These are the 3 times when all 3 of them are going to meet. And this continues, but we need to check for only 180 days. So within 180 days, yes, 60 days after 120 days and 180 days. So 3 days they are going to meet on the same day. So the correct answer for this is going to be what? We need to tell the number of times. The answer is 3. In the similar manner, we will do it for other questions. Let's take another question. 5% firing bullets at a target with the intervals of 6, 7, 8, 9 and 12. Okay? The number of times they would fire the bullets together, again look at it, together at the target in an hour. So in 1 hour we need to find. See, in 1 hour we need to convert everything into seconds. In 1 hour we have 60 minutes and into 60 seconds. So 3600 seconds are there. Now we need to find the LCM of all these 6, 7, 8, 9, 12. Whatever the number comes. So that is the time period or interval at which all of them are fired simultaneously, and we will divide this 3600 with that number to find how many number of times they would fire simultaneously within an hour. Simple. Okay, same application. So first we will begin with the 2 fours. Okay, 9 and 2 sixes. Now we can see another 2 can be done here. Okay, 7, 2, 9 and 2 3s. Now 2 is all gone. Even if we take 2, only 1 will come, that will multiply it. Now we can go for 3. 3, 7 is prime, we can keep it as it is. 3 3s and 3 1s. Now look at them, all of them are prime numbers. We simply have to multiply to find the LCM. So LCM of all these numbers will be 2 into 2, 4, 4 into 3, 12 into 7 into 6, that is 42. Okay. So whatever the number, that will be the resultant of LCM. Now either you can multiply it and divide this, or simply you can put number 12 into 42 here itself. Anyway, we need to divide this with 3600, and the resultant, whatever that we get, just simply see 6 times 6 2s, 6 hundreds. Then similarly 6 7s, 6 hundreds. 2 1s, 2 50s. So resultant is 50 divided by 7. So 7 means you can write this as 7 into 7 plus 1, because 7 into 7 49 plus 1. So 7 times you can have simultaneous firing of it. Okay, that means after 7, then you have this 14 21 in this manner. Okay, so if you check it here, because it is dividing it, right? So 49 tak 7 times plus 1 it goes. So the number of times altogether the bullets are going to fire is 7 here. That is how we get to the conclusion. Next, same application. A bell rings every 18 minutes. Okay. So a second bell, first bell rings at every 18 minutes interval, second bell every 24 minutes, third bell every 32 minutes. If all three bells ring at the same time, so all of them rang at 8 o'clock in the morning, 8 a.m. Now, what is the time they will be ringing all together again? Again, this is the application of LCM. You need to find the LCM of these three numbers, and whatever the resultant that you are getting, you'll simply check. You simply add that much of time to this 8 a.m. This is new again. Let me do it. Okay. We will begin with 2 9s, 2 12s, and 2 16s. Again, 2 can give you. Okay. Again, 2 will give you. Say you can go with the bigger number also. Better always go with the smallest prime number. If all the things are done, then you can go for the other, so that error can be reduced. Okay. 3s and 4s. Now 3. Of course, 2 into 2 can happen, but that is going to give you the same 4 number. That's the reason why I'm not doing it to this. Okay, 3 1s and 4. Even if you take 3 again here, it is going to give you 3 1s. So same multiplication. Even if you going to take 2 into 2, same number is going to come. So you can multiply simply. Okay, this will be the resultant LCM. What is it? 8 into 9 into 4. So these many minutes. Simple. So what is the resultant of 8? 36. 8 into 36. So 36 into 8 minutes. But we need to convert this into, okay, we need to find actual number, then convert it into hours as well. So 8 6 are 48, 24 and 28. 288. 288 minutes. Okay, we need to convert it into hours divided by 60. Say 60 into 4, 240. So 4 hours plus 48 minutes. Now this is the time interval after which they are again going to rank simultaneously. Morning 8 baje they rank together. Now you just add this much of time. It is going to become 12 hours 48 minutes. Okay. So this is when they are again going to rank simultaneously. The answer will be B here. Okay. Next goes again same. In a school, every student is assigned a unique identification number. A student is a football player if and only if the identification number is divisible by 4. See again, divisibility, some people will apply the divisibility rule here, but look at the question completely, you will get the idea. So divisible by 4, and whereas a student is a cricketer if and only if the number identification is divisible by 6. Then the question is, if every number from 1 to 100 is assigned to the students, that means there are 100 students and their identification numbers are assigned, then how many of them play cricket as well as football? See, had it been either cricket or football, you would only count the multipliers of 4 and multipliers of 6 and just see the numbers. Add those two numbers and you will get the players, either playing cricket or football. But now what you want? You need such a student who play cricket as well as football. Okay, so that means you need such numbers which are divisible by 4 as well as 6 both. So whenever you wanted to find such numbers which are divisible by more than 2-3 numbers, what you need to find? You need to find the LCM of those numbers. Simply if you find the LCM of numbers, these numbers, whatever the resultant that comes, the multipliers of it will be divisible by both these numbers. That's the logic. Okay, so what is the LCM of this? 2 2s, 2 3s, that's it. All prime numbers are there. This is 12. Now the multipliers of 12 in 1 to 100 numbers are going to be divisible and are going to be the ones which are divisible by both 4 and 6. That means they are both cricket players as well as football players. Simple answer aa gaya. So what are the multipliers of 12? 12, 24, 36, 48, 60, 72, 84, 96. If you add another 12, it will go to beyond 100, but we need till 100 only. So how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. So the correct answer is 8 such students are there who play both cricket as well as football based on the identification number given to them. Simple. Okay. Next question. Sita and Geeta go for a swim after a gap of every 2 days and every 3 days respectively. If on January 1st, both of them went for a swim together, when will they go next time? Again, you need to find the LCM of these days after which they are going to the swim. But here is the catch. Here they are not saying exact day. They are saying the gap. Let's say Sita is going on this day. Okay, let's say first she is going on 1st of any month she is going. Then there is 2 days gap. That means on 2nd and 3rd she is not going. She is going on the 4th. That's the meaning of it, right? So there is 2 days gap. That is, she is going on the 3rd day. When we say the gap, the actual day on which she is going, 3rd. Similarly, if you say gap of 3 days, that comes out to be 4th day. So here we need to keep that 2 days gap. So it is going to be the 3rd day and 4th day. If you see at what regular intervals they are going. So that's where this is going to be little bit different. Here also we'll find the LCM, but we don't find the LCM of 2 and 3. Rather we find the LCM of 3 and 4, because this is going to be 2 plus 1, it is going to be 3 plus 1, because gap bata rahe na, they are telling the gap. So put that gap and it is coming around to be 3rd day and this is going to be 4th day. So it is going to be the LCM of 3 and 4. So even if you put 2 into 2 same aayega, and 3 3 1, so you simply have to multiply. This is going to be 12. Okay, and that means after a gap of 12 days, both of them are going to go for swim again. So 1st January is done. Then next they are going to go at 12 days. It will be 30th January. Simple. So the answer is going to be D. Okay. Next, another question. Look at this. What is the smallest number greater than 1000 that when divided by any of the numbers, यहाँ पर सारे numbers दे दिया है, which leaves a remainder 3. So what we need to find? We need to find the LCM of all these numbers. So the least common factor is going to divide each of these numbers. So we need to find that. and we need to see how many number of times that is there within 1000. But what we need is actual divisor plus we need a remainder of 3. So we need to add that 3. So let's look at how to solve this question. First and foremost, we need to find the LCM of 6, 9, 12, 15, 18. So क्या जाएगा 2, 3, 9, 6, 15, 9. ठीक है. Now again 3. 3 ones, 3s, 2s, 5s and 3s. Again 3. That's it. ठीक है. Now all the numbers are prime. So this is going to be 6 into 3, 180. So 18 into 10, 180. That's what we get it right. 10, 30, 33 is 90, 90, 2 is 180. So 180 is the LCM. Now within 1000, see within 1000, what are all the numbers that are divisible by 180? They will be divisible by each of these numbers, all of these numbers. But we need remainder 3. What we will do at the end is we will add that 3 to those numbers and you will get the numbers. Okay. But we need to see what is the smallest number greater than 1000. First, let us see in 1000 how many times 180 comes. I think 5 times, because 5 times it is going to cover 900. See, into 5 this will be 900, because 10 times 1800, 5 times it will be 900. So 900, yes, till 900 there will be 5 times which will be divisible, but we don't want it. We want the number which is greater than 1000. So if I add another 180, this is going to be 1080. So this will be the smallest number which is greater than 1000, which is divisible by all these numbers. Okay, but what we need is the smallest number greater than 1000 divisible by all these numbers, but leaving a remainder 3. So what we need to do to this number, this is a perfect divisor. Okay, it is divided by all these numbers, but we want a remainder of 3, so we'll do plus 3, and 3 is clearly smaller than any of them, so it is going to give the remainder 3 as it is. So the resultant number which we require is 1083. Simple. Okay. So this is another type of questions which have been asked on the basis of LCM application. See, this is 2023 question. Same application जैसे हमने bells ringing at the time किया था, same application. So it is on traffic signals, turning of the traffic signals from green to red and then red to green. The intervals are being given 25 seconds, 39 seconds and 60 seconds. Okay. And simultaneously they first turned together green at 2 p.m. Then what is the next time that is being asked? Okay. Simply find the LCM of it. LCM of these 25, 39 and 60, that will come in seconds. Convert this into minutes or hours. Then add that time to this time, whatever the resultant will be the answer. So now all of you, I want all of you to solve it and put it in the comment section. Okay, I wanted to see whether you are doing it or not. That's it. So this is all about this particular one. So thank you very much, and practice as many questions as possible from wherever test series or CSAT books or whatever. But this segment is also going to help us at least one question, that is 2.5 marks with an easy concept. Okay. So that's it, guys. See you in the next Saturday with another segment, other topic. Okay. Bye everyone. Take care.